Hey, howdy, space nerds. This week marks the 6-month B-Day of this podcast. So before we get started, I just want to thank all you loyal listeners for joining me every week as we explore exploration. Because of you, this show was downloaded about 250,000 times in more than 70 countries so far. But we've got a lot more exploring to do, so thanks for sticking around. All right, on with the show. From the studios at WMFE in Orlando, Florida, this is the Space Exploration Podcast that asks the question, are we there yet? Hi, I'm Brendan Byrne. What's it like to walk on Mars? Well, I'm sure if you've listened to this podcast, you've at least thought about that question. And thanks to Microsoft's HoloLens technology and the incredible engineers over at NASA's Jet Propulsion Lab, you can now experience what it's like to walk on Mars. Destination Mars is an exhibit that uses an augmented reality headset and real images from the Mars rovers to put people on the surface of Mars. Now, I'm not going to lie, I was a bit skeptical at first when I heard about this, but the folks at the visitor complex invited me down to try it out, and let me tell you, it was incredible. It really gives you a sense of scale, just how massive things are, and how incredibly similar the Martian surface is to ours, albeit a bit redder. And also, hologram Buzz Aldrin guides you through the experience. Now, I learned that the exhibit at KSC was based on real technology that scientists use right now to determine where Curiosity should explore next. Now, I spoke with Doug Ellison, he's a visualization producer at NASA's JPL, about the technology and how it went from the noggins of scientists to visitors like me at the Kennedy Space Center Visitor Complex.
It's very simple. Destination Mars lets people walk on Mars, and not some Hollywood-style artist impression of what Mars should be like, but actual Mars as seen by the Curiosity Mars rover that's exploring Gale Crater right now. You don a headset, and in about a 30 by 20 foot space, you can walk around completely freely. And we've used 3 of the best sites that Curiosity has explored, where we've made interesting scientific discoveries, where the terrain's particularly beautiful, and it is just like being there. It is Mars in all its glory.
It's real images, right? There's no artificial imaging there. That's the real thing, right?
It's the real thing. It's a merge of data from multiple sources. So we start. We have a terrain pipeline that runs every time we actually get new data from the rover, because our scientists are using on-site, which is the core of Destination Mars, every day to figure out where to send Curiosity and to understand the geology of the rover's surroundings. And so our terrain pipeline actually starts every time there's new imagery from the rover. We start with a baseline of 3-dimensional data, but from the Mars Reconnaissance Orbiter, the best orbiter we have around Mars right now. Amazing, like Google Earth quality images. We then take stereo data from the rover's cameras. So all the cameras are in pairs, so we can see depth just the same way humans have 2 eyes to see depth as well. We take that 3D data, we overlay that onto the orbital data, and then we apply to that 3D model all the imagery from the rover. And then we use the best imagery in every single location we can. It's the best imagery, and then we fall back to the lower data imagery when we have to, if we've got gaps. So the 3 sites we have in Destination Mars are all places where the rover spent quite a lot of time. And so we have lots of images from lots of nearby locations to make a complete, coherent 360 color 3D model of that environment. For our scientists, it's not always that beautiful. Sometimes it's a little bit of orbital data, some black and white rover data, and some color rover data, but it's still enough for them to understand where the rover is and some of the geological context they need to understand what science Curiosity is learning.
Now, this experience, as you say, came out of that on-site project. Can you kind of tell us how scientists are using the technology that I just used to walk through Mars to actually help better explore Mars?
So, in the Ops Lab, which is our small team at JPL involved in kind of mission operations innovation, we made a realization about 3 years ago. We actually did a full-on blind study. We had scientists using the traditional planning tools to decide to try and draw a map of some waypoints we put in a panorama for them. We took the same data and we let them walk around it in a very crude virtual reality headset that was positionally aware. They could walk around, and we asked them to draw a map of some waypoints. The waypoints as drawn by those in a positionally aware immersive experience were dramatically better than just trying to figure it out from flat panoramas. It was like this light bulb went off, like, we are really onto something here. And the realization is that when we can present science data to planetary scientists, geologists, if you will, in the same way that they would if they were just in a field site, if they'd gone to the Mojave Desert or the scablands of central USA or some mountains, whatever. If they'd gone there, there's no interface. They're not clicking around a panorama. They just stand up. They have a look around. They understand the environment. And so that's what our scientists do. They put on the HoloLens and they are standing on the surface of Mars and they can understand the terrain, the location, and the geology in context. And that is how geologists do work in the field here on Earth. And with this technology, we can make them do the same thing, but from, as of today, it's 95 million miles away on the surface of Mars.
And we were talking earlier that, for my job as a journalist, it's trying to explain what I'm seeing, and it's very difficult when I've never seen it myself. So to be able to see it, it's really cool. And then in the experience, you kind of overlaid other things. So you kind of overlaid what Mount Everest would look like in comparison. So it gives you a sense of scale.
So once you've crossed the technical barrier of, I can put on a device and I can stand on Mars without any sort of interface and I can understand it. Well, then we can start giving you superpowers, right? We can break the rules of physics here, and we can say, right, we're going to put some science in context. In the case of our scientists' tools, they're doing things like annotating the terrain, they're meeting together in a location on Mars, even though they're not in the same office here on Earth, or not even in the same country here on Earth. We can give them a magical ruler to start measuring the lengths of outcrops or the heights of rocks and so on and so forth. So Destination Mars, we dip into that toolkit just a little bit. We try to give people their scientific fruit and veg, right? They should come away having learned something. And so we litter one of our 4 sites with some little scientific nuggets. This is where the rover drilled a hole so we could learn something about the inside of these rocks. These cracks on the rock are because once long ago this was the bottom of an ancient lake, and as the lake dried, the rocks cracked. Or over there's a mountain that's 5.5 kilometers tall. That's almost the size of Mount Everest. And by being able to put that information in the exact location that it belongs, it changes how well people can understand that stuff. It's genuinely transformational. People can come away having go, you know what, I get it now, I understand. So the rover, you see a long outcrop of rock, and so you can zap it with your laser, and then that means you know what it's made of, and then you can drill it because inside's more important than just on the surface. They suddenly have an understanding of not just what this environment looks like, what Mars really appears to be, but also the science we've done and how we do that science. And to be able to, underneath it all, say this is a true, honest, authentic experience, the same way our scientists are exploring Mars, that's very, very powerful.
And you meet Curiosity, which some people who have never seen it before it launched, it's a big rover.
She's a big beast. She's as Arissa says in Destination Mars, 7 feet tall, 2,000 pounds, 6-wheel drive, riding on 20-inch titanium rims. Curiosity is a big rover. Her wheels, she's basically the size of a Mini Cooper. That's how big Curiosity is. And one thing we did outside Destination Mars, for the area where people are just getting ready to go inside, we actually put some silhouettes of our family tree of rovers on the wall, and they're life-size too. And you see this life-size silhouette of Curiosity, like, that's really, really big. And even if it's only subconsciously, you throw that in the back of your mind, in you go to Destination Mars, and then suddenly, along the terrain, driving straight towards you is the Curiosity rover, and you're like, whoa, it really is that big. It's a really big thing. And people are like, wow, it's a really big thing. How do you land a big thing on Mars and stuff like that? So, and of course, you've got Arissa, one of our rover drivers, actually right there next to the rover to explain what it's doing there and how it does it.
How does having this technology, and we'll go back to the public experience, but how does having this technology help people like Arissa do her job when scientists are able to kind of immerse themselves in the same environment altogether?
So, the plural of anecdote isn't data, but I'll give you a good anecdote. The last scene in Destination Mars is a place called Dingo Gap, and it's a large sand dune that bridges across, it's kind of a small little valley. It's maybe only 5 meters high on each side, and the sand dunes maybe only a meter or so tall. Back when Curiosity arrived at that location, on-site wasn't actually a thing. We were still working at it, and it wasn't something we could share with the world yet. And the engineers were highly stressed about, do we try and drive over this sand dune? If they decided not to, there was a bit of they'd have to do a big drive around to get to where they wanted to go by avoiding that sand dune. It was going to be a major diversion. And eventually they kind of did a little test. How well did the wheels react in the sand dune? They looked up kind of data that they have from our Mars yard where they practice driving Mars rovers around. How well does the rover drive over the sand dunes and things like that? And eventually they decided, yes, we're going to go over the sand dune, and very cautiously they went over, took pictures on the way, and drove over the other side. Some of the engineers who then saw on site were like, oh, that's easy. We could have driven over that. It's fine, right? They instantly, the moment you look at it in the way that is natural to humans, it is a step-level change in your ability to understand the terrain. And that terrain presents not just an opportunity for our scientists to understand the ancient record of Mars's geology, but also represents a challenge to our engineers who've got to try and drive around this stuff. Mars is not a parking lot, and there are places where you have to make hard decisions about, well, we'd like to get to that rock over there, but this terrain looks pretty rough. We're going to have to go around, or maybe skip it altogether. Maybe we can't get to this particularly good piece of science. So being able to just explore it in the way that is natural, no interface, with your Mark I eyeballs, that is, as I said, it's this step-level change in understanding the terrain, the science, the context of the science. And we've got a team of scientists around the world right now who are dipping into this every single day to make decisions about where to send Curiosity next.
Could you see this applying to other missions or other applications?
So we're already working with the team responsible for the next Mars rover, the 2020 rover, that's going to look very, very similar to Curiosity, and its main job will be to start collecting samples for later return to Earth. And OnSite will be a part of their planning cycle. They're trying to make a more aggressive planning cycle so they can use the rover more quickly, use it kind of on more of the days that are available to them. And so being able to drop a HoloLens on, have a look around, make some decisions and get going will hopefully help the team kind of have a more accelerated tactical process. At JPL, we're also using immersive technology outside of just walking around Mars. With HoloLens, we've developed a tool called Protospace. And Protospace is for our engineers who are actually designing spacecraft. Now, it's a magical 3D printing button, if you like. They can take their highly complex CAD files that take 10 minutes to load on a huge workstation, and they clunk along at 1 frame per second, and it's the same problem that our scientists have. They're looking at a 2D picture of this 3D thing. Protospace, we process that CAD file, we shrink it down so it will play on one of these devices, and then we can summon it full size right in front of the engineers, and they can walk around it. They can stick their head inside the next Mars rover. They can check clearances for fitting electronics boxes inside a small piece of spacecraft. And we're already finding cases where an engineer who's designed a whole sequence of assembly for a future spacecraft has gone, you know what, if I put this box in here first, I'm not going to have clearance for my wrench to bolt this box on next door, so I'm going to have to bolt them around, I have to do the other one before this one. They learn, and we're catching mistakes long before we're cutting metal. And it's much, much cheaper to learn those mistakes in the virtual world before you're thinking, I've got to now rebuild this stuff, I've got to remake stuff, change procedures. We can also rehearse a procedure. Now, you've seen at the back of Curiosity, it's got this big chunkin radioisotope thermoelectric generator, the RTG, that gives Curiosity her power. The 2020 rover will have the same thing. But there's some changes to the chassis on the 2020 such that we've got this, looks like a shopping cart handle across the back of the rover. And we've also got an instrument actually tucked just underneath where the RTG is, a ground-penetrating radar. And those mean that when you install the RTG, you've actually not got much clearance between the shopping cart handle at the top and the new ground-penetrating radar underneath. And what many people don't know is that the RTG for a spacecraft, it doesn't get bolted to the rover weeks in advance. That RTG will be fitted to the back of the rover when the rover is mated to its descent stage, upside down in its entry capsule with its cruise stage attached on top of the upper stage of the rocket inside its fairing at the launch site here in Florida. And they have a special hatch on the fairing, they open that, a special hatch on the back shell, they open that, and they insert the RTG into the back of the rover through all of this furniture that's around them. And with Curiosity, they actually built an entire rig, a mock-up of the back shell, the fairing, the back of the rover, the RTG, and all the rig they were going to use to mate the RTG into the back of the rover. Well, we were able to summon all of that hardware using a mixed reality headset, and the engineers could actually lie on the ground and check their sight lines and go, yeah, when I put the RTG through here, I'm going to be able to see my bolts, so I can bolt this thing in, and we're going to be able to, plug those cables in so that our rover is powered, without having to go to the expense of building all this incredibly expensive and complicated test rig. They've now done that virtually, and so they rehearse. So when it comes to bolting that RTG to the real rover, it'll be out at pad 40 here pad 41 out at the Atlas V pad here. They'll have already done it in their minds, and so it'll be a faster experience, a quicker experience, and a more reliable experience. I think there's less chance of something going wrong when you've already visually rehearsed that experience.
Don't want to mess around with plutonium, right?
Well, we all learned what Matt Damon said in The Martian, so I think we can all take our lessons from him.
Now, just going back to that last scene in the public experience that you see here at Kennedy Space Center Visitor Complex, there is that habitat that's there. How much is that based on NASA's plan for a habitat there, or did you take some creative liberties there?
So we took a few liberties. We wanted to kind of throw out there it's not going to be like the first Mars landing, or maybe not even the second Mars landing, but what if we've decided we found somewhere that we want to perhaps assemble a base over a number of missions? What might that look like? And we started with what are the notional surface assets. In fact, NASA has this wonderful 3D model library that you can download online for, you can 3D print yourself an asteroid and stuff like that. And there's actually what we think our big human Mars rover will look like, what we think our Mars base will look like, what we think our big spacesuit will look like. And so we started with those, and then we threw a little bit of artistic license at them. So we added some nice geodesic domes onto the habitat, and we put some headlights on the rover, and the spacesuit's kind of halfway between what we might use and what Matt Damon wears in The Martian, because it looks so good. And it's based on reality. We started with the real pieces that will end up going to Mars. And I think it's quite an emotive moment. And Buzz's line about, we'll look at the sun as it sets on this new horizon and marvel at how far we've come. These 95 million miles to Mars, and then gaze at destinations beyond. Because when it comes to human exploration, Mars is the next big thing, but there are more destinations beyond that as well. And it's a nice note to end the experience on.
And that rocket launched a little close to the habitat. I don't think the NASA safety folks would be happy with that.
we want to make sure it was visible and looked awesome. And you'll notice there's some big subwoofers up there turned up to 11, and so there's a nice kind of shake, rattle, and roll. I imagine, we'll probably be tucked behind a hill or tucked inside a little crater somewhere just to make sure no one gets hurt.
Now, Doug, what's the one thing that you hope that every guest that walks through this experience can take away from Destination Mars?
It's a reality that people have begun to forget that space exploration is a real thing that's happening right now. We may not be right now launching astronauts from US soil, but we are all on Mars together with the Curiosity rover. It's a big chunk of metal that was built by people, but through it, these people are now on Mars. Exploration is happening right now on the surface of Mars. Curiosity is genuinely paving the way for humans to follow in her tracks on the surface of Mars. There are instruments on board Curiosity, and there will be on the 2020 rover that are specifically there so that we can be ready to send people in our lifetime. And it's very easy to forget that. It's very easy to think, a lot of people think, NASA shut down, a few years ago, it's all over, no one's launching space shuttles anymore, it's all over. It really isn't. The Space Coast here is getting busier and busier and busier. At JPL, we're building a new Mars rover. We're operating 2 Mars rovers right now and a fleet of orbiters. And so to be reminded of just how busy space is, just how much is going on, I think people will go away kind of reinvigorated about space exploration. With Buzz's words, hopefully it'll inspire people to do more and go further. And I think that's something that all of us can learn to do just a little bit of.
Doug, thanks so much for speaking with us.
Absolute pleasure. Thank you.
Well, that's going to do it for this episode. Support for Are We There Yet comes from the listeners of WMFE. Follow the show online. We're on Twitter at AWTYMars. Or reach out to me in the Twitterverse. I'm at SpaceBrendan. Leave us a review on iTunes. That's how more people learn about this podcast. Are We There Yet is a production of WMFE, and our theme music was composed by Kevin McLeod. For more space news, visit us online at WMFE.org/space. Until next time, I'm Brendan Byrne. Thanks for listening.